Hello guys, in this video I would solve a question based upon Kirchhoff's voltage law. In this question, I would point out the major mistakes commonly students do while solving the KVL based different problems. So let's proceed here. There are certain procedure to start here. First of all, I have to mark the tagging named as this is source voltage Vs1, this is source voltage Vs2, and it is the series connected circuit. So the current flowing will be the same. I have marked the polarity of the current, that is my I current I. Series current flowing is same. For the second step, I have to write the master equation of the Kirchhoff's voltage law based upon the signs. I have to write first, I have to write the equation based upon the first sign in every loop. So it will be minus into given voltage Vs1. First is first. Next is the first symbol is plus V1. Next is minus Vs2. Next is minus V2 is equal to 0. I have write this is the master equation of KVL based upon the polarities marked. If not given polarities, you have to mark polarities on your own. Okay. Now in the next step, I have to put the values of given voltages. So for Vs1, my given as 32 volts plus V1 minus Vs2. Vs2 either it would be plus 8 volt or minus 8 volt. The already given value is minus 8, so I have to write the exact value that is given here. Minus V2 is equal to 0. So solving it, minus 32 plus V1 plus 8 minus V2 is equal to 0. Minus 32 plus 8 will be minus 24. Minus 24 plus V1 minus V2 is equal to 0. 24 is negative sign here. You have to take it to on other side. V1 minus V2 is equal to plus 24. This is my equation number 2. At this point, what will be the next step? We are given the resistor values and current series is the same. So for the next step, we have to start here. V is equal to IR based Ohm law. V is equal to I times 4. V1 will be equal to I times 4 ohm, which will be equal to 4I. And V2 will be V2 will be V2 will be I times IR. As you know that there was current entering into plus sign, that's why I have write to plus current, and it is here current is in opposite direction of the symbol, so it will be minus I times 2. Okay, this is the major turning point. It will be minus 2I. So V1 V2 values are given here. I have to put into this equation and I will proceed. V1 was equal to 4I, V1 was equal to 4I, and V2 was equal to minus 2I is equal to 24. And it will be 4I minus into minus plus 6I. 4I plus 2I is equal to 6I is equal to 24, and I is equal to 24 by 6 or 4 ampere. This is my current value. So based upon V1 and V2 values of equations, V1 will be equal to 4 into I, that was my 4 ampere, this is equal to 16 volts. And V2 is equal to minus 2I, that is equal to current times, sorry, minus 2I. Minus 2 into I is equal to my 4 ampere, this is equal to minus 8 volts. So these are the final values of V1 and V2. For the next step, and it is the very important step, that you have to put back values of V1, V2, Vs1, Vs2 into my final equation, this equation, and if you get 0 result, it means your final question answer is true. So put values here. You will have minus 32 plus V1, that was equal to 16, minus Vs2, Vs2 was minus 8, and V2 was equal to minus into V2, you have found out minus 8. You have to solve this equation is equal to 0. So minus 32 minus 16 plus 16 into minus 16 minus minus plus 8 minus minus plus 8 is equal to 0. Minus 16 plus 16 is equal to 0. 0 is equal to 0. It means your values of V1 and V2 that you have solved at the end, that are V1 is equal to 16 volts and V2 is equal to minus 8 volt. That is the right answer. You don't need to think about that either it's my right answer or wrong answer. Just you have to find the final solution. You have to put back into the original equation and you will get the final answer. Hopefully you have understood the reason behind solving and the concept behind solving the KVL based numericals. Please like, share and subscribe to my channel.